The National Electrical Code does not explicitly address the use of spare conductors in panel boards. However, it does provide guidance on the installation and use of conductors in general. NEC Article 300.15 addresses excess conductors. This article states that excess conductors of the same circuit size and insulation type installed in raceways, cables, or cords shall be grouped together and terminated. NEC Article 300.17 addresses the number of conductors in raceways and cables. This article limits the number of conductors that can be installed in a raceway or cable based on their size and insulation type. It also requires that the conductors be installed in a manner that facilitates their identification. Based on these articles, it can be inferred that spare conductors can be installed in a panel board, provided firstly, they are grouped together and terminated, secondly, they do not exceed the allowable number of conductors in the raceway or cable, and thirdly, they are installed in a way that allows for easy identification. While the NEC does not explicitly require the removal of unused conductors, it is considered best practice to do so for the following reasons. Firstly, it reduces the risk of confusion or accidental connections. Secondly, it improves the aesthetics of the installation. Thirdly, it facilitates future maintenance or modifications. If spare conductors are left in place, they should be clearly marked as such using labels or other appropriate methods. This will help to prevent them from being accidentally used or confused with active conductors. It is recommended that the electrical contractor remove the unnecessary spare conductors from the panel board. However, if it is deemed necessary to leave them in place, they should be grouped together, terminated, and clearly marked as spares. When installing conductors in electrical systems, particularly within panel boards, understanding and adhering to the National Electrical Code is crucial. While the NEC doesn't specifically mandate the removal or presence of spare conductors, it does offer guidelines that influence how these conductors should be managed. Let's explore the relevant aspects of the NEC and delve into best practices for dealing with spare conductors. The NEC stance on spare conductors is somewhat indirect. It doesn't explicitly say you must remove spare conductors or you must include spare conductors. Instead, it focuses on the overall safety and organization of electrical installations. This means that any decision regarding spare conductors must align with the broader principles of the code. Article 300.15 of the NEC, which addresses excess conductors, provides important context. This section stipulates that if you have extra conductors of the same size and insulation type within raceways, cables, or cords, they should be grouped together and properly terminated. The intent here is to prevent loose, unterminated wires from creating potential hazards. Termination ensures that the conductors are safely secured and don't pose a risk of accidental contact or short circuits. Article 300.17 deals with the number of conductors permitted within raceways and cables. This is a critical aspect because overcrowding can lead to overheating and insulation damage. The NEC sets limits based on the size and insulation type of the conductors to ensure adequate heat dissipation and prevent insulation breakdown. The requirement that conductors be installed in a way that facilitates identification is also important. Clear identification makes it easier for electricians to trace circuits, perform maintenance, and troubleshoot problems. This is especially crucial in complex electrical systems. From these articles, we can infer several key points about spare conductors in panel boards. Firstly, spare conductors are permissible as long as they adhere to the general requirements of the NEC. Secondly, these conductors must be grouped together and properly terminated to prevent hazards. Thirdly, the total number of conductors, including spares, must not exceed the allowable limit for the raceway or cable. Fourthly, the spare conductors should be installed in a way that allows for easy identification. Although the NEC doesn't mandate the removal of spare conductors, industry best practices often favor their removal when they are not needed. There are several compelling reasons for this recommendation. The presence of unused conductors can create confusion, especially during maintenance or troubleshooting. It's easy to mistake a spare conductor for an active one, leading to errors or even dangerous situations. Removing unnecessary conductors simplifies the system and reduces the potential for mistakes. A clean and organized panel board is easier to work with and presents a more professional appearance. Removing spare conductors contributes to a neater installation, making it easier to trace circuits and perform modifications in the future. Unused conductors take up space within the panel board, which can be a valuable commodity, especially in compact installations. Removing them frees up space for other components or future expansion. Despite the advantages of removing spare conductors, there are situations where leaving them in place might be justifiable. If there is a reasonable expectation that the conductors will be needed in the near future for planned expansions or modifications, it might be more practical to leave them in place. However, this decision should be carefully considered, weighing the potential benefits against the risks of confusion and clutter. If the decision is made to leave spare conductors in place, it's essential to manage them properly. This means grouping them together, terminating them securely, and clearly marking them as spares. Proper marking is crucial to prevent accidental use or confusion. Labels, tags, or other identification methods should be used to clearly indicate that the conductors are spares and should not be connected to any live circuits. In summary, the NEC provides guidance on the installation and management of conductors, but it does not explicitly address the use of spare conductors in panel boards. The decision to remove or leave spare conductors in place should be based on a careful assessment of the specific circumstances, considering factors such as future needs, potential for confusion, and available space. Regardless of the decision, all conductors must be installed in accordance with the NEC and industry best practices to ensure safety and reliability. If spare conductors are left in place, they must be properly grouped, terminated, and marked to prevent hazards and facilitate future work. The recommendation is to remove unnecessary spare conductors from the panel board. However, if it is deemed necessary to leave them in place, they should be grouped together, terminated, and clearly marked as spares. Terminating conductors properly is a fundamental aspect of electrical work, ensuring safety, reliability, and code compliance. There are several key considerations when terminating conductors, each playing a crucial role in the overall integrity of the electrical system. The type of conductor being terminated significantly influences the choice of termination method. Solid conductors, stranded conductors, and aluminum conductors each have unique properties that require specific techniques and connectors. Solid conductors are typically used in residential wiring and some commercial applications. They are relatively stiff and can be terminated using screw terminals, push-in connectors, or crimp connectors. Stranded conductors are more flexible than solid conductors and are commonly used in applications where vibration or movement is present. They require special connectors that can accommodate the strands without damaging them. Crimp connectors, compression connectors, and wire nuts are often used for terminating stranded conductors. Aluminum conductors are lighter and less expensive than copper conductors, but they are also more susceptible to corrosion and oxidation. Special connectors and termination techniques are required to ensure a reliable connection and prevent corrosion. Antioxidant compounds are often used to protect the aluminum from oxidation. The size of the conductor is another critical factor in selecting the appropriate termination method and connector. The connector must be properly sized to match the conductor gauge to ensure a secure and reliable connection. Undersized connectors can lead to loose connections, overheating, and even fires. Oversized connectors can damage the conductor or make it difficult to achieve a proper termination. The type of equipment being connected also influences the choice of termination method. Different types of equipment have different terminal configurations and requirements. Panel boards, circuit breakers, receptacles, and lighting fixtures all have specific terminals designed for particular types of conductors and connectors. The environment in which the termination is being made can also affect the choice of materials and methods. In wet or corrosive environments, special connectors and enclosures are required to protect the termination from moisture and corrosion. In high-temperature environments, heat-resistant connectors and insulation should be used. The tools used for terminating conductors are just as important as the connectors themselves. Proper tools ensure that the termination is made correctly and safely. Wire strippers are used to remove the insulation from the conductor without damaging the wire. They come in various sizes and types to accommodate different conductor gauges. Crimpers are used to compress crimp connectors onto the conductor, creating a secure and permanent connection. Torque screwdrivers are used to tighten screw terminals to the proper torque, ensuring a reliable connection without over-tightening. Voltage testers are used to verify that the circuit is energized before working on it. This is essential for preventing electrical shock. When terminating conductors, it's important to follow a step-by-step procedure to ensure a safe and reliable connection. Firstly, always de-energize the circuit before working on it. Verify that the circuit is de-energized using a voltage tester. Secondly, prepare the conductor by stripping the insulation to the proper length. Use a wire stripper to avoid damaging the wire. Thirdly, select the appropriate connector for the conductor size and type. Make sure the connector is clean and in good condition. Fourthly, insert the conductor into the connector and secure it according to the manufacturer's instructions. Use the correct tool for the connector type. Fifthly, inspect the termination to ensure it is secure and properly made. Check for loose strands or exposed conductors. Sixthly, label the conductor and termination for future identification. Use a permanent marker or label maker. Finally, test the connection to verify that it is working properly. Use a multimeter to check for continuity and voltage. There are several common mistakes to avoid when terminating conductors. Firstly, do not over-tighten screw terminals. Over-tightening can damage the terminal or the conductor, leading to a loose connection. Secondly, do not under-tighten screw terminals. Under-tightening can also lead to a loose connection, which can cause overheating and arcing. Thirdly, do not use damaged or corroded connectors. Damaged connectors can compromise the integrity of the connection and lead to failure. Fourthly, do not mix aluminum and copper conductors without using a compatible connector. Mixing these metals can lead to corrosion and failure. Fifthly, do not overload circuits. Overloading can cause overheating and damage to the conductors and equipment. Sixthly, do not ignore warning signs such as flickering lights, burning smells, or hot outlets. These signs may indicate a problem with the wiring or terminations. In addition to following proper termination procedures, it's also important to comply with all applicable codes and standards. The National Electrical Code provides detailed requirements for conductor terminations, including conductor sizing, opacity, and grounding. Local codes may also have additional requirements. Regular inspection and maintenance of conductor terminations are essential for ensuring the long-term reliability and safety of electrical systems. Termination should be inspected periodically for signs of corrosion, looseness, or damage. Loose connections should be tightened, corroded connectors should be replaced, and damaged conductors should be repaired or replaced. Infrared thermography can be used to detect hotspots in electrical systems, which may indicate loose or corroded connections. This technology allows electricians to identify potential problems before they lead to failures or fires. Proper conductor termination is a critical aspect of electrical work, requiring attention to detail, knowledge of codes and standards, and the use of appropriate tools and materials. By following best practices and avoiding common mistakes, electricians can ensure that electrical systems are safe, reliable, and code compliant. The importance of proper grounding in electrical systems cannot be overstated. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. A properly grounded system also reduces the risk of fire and equipment damage. The National Electrical Code provides detailed requirements for grounding electrical systems, including conductor sizing, grounding electrode systems, and equipment grounding. Grounding electrode systems typically consist of a ground rod, ground plate, or underground water pipe that is connected to the grounding conductor. The grounding conductor is then connected to the neutral busbar in the panel board and to the equipment grounding conductors throughout the system. Equipment grounding conductors provide a path for fault current to flow from the equipment back to the grounding electrode system. These conductors are typically run with the circuit conductors and are connected to the metal enclosures of equipment and appliances. Ground fault circuit interrupters are another important safety device that can help prevent electrical shock. These devices monitor the current flowing in the circuit and trip the circuit breaker if they detect a ground fault. GFCI receptacles are commonly used in bathrooms, kitchens, and outdoor areas where there is a risk of exposure to water. Surge protection devices are used to protect electrical equipment from voltage surges caused by lightning or other sources. These devices divert the surge current to ground, preventing it from damaging sensitive electronic equipment. Regular testing of grounding systems is essential to ensure that they are working properly. Ground resistance testers can be used to measure the resistance of the grounding electrode system. A low resistance reading indicates that the grounding system is effective. Visual inspections can also be used to check for loose connections, corrosion, or damage to grounding conductors. Proper labeling of electrical panels and circuits is essential for safety and maintenance. Each circuit breaker or fuse should be clearly labeled to indicate what it controls. Panel schedules should be kept up to date and accurate. Warning signs should be posted to alert people to potential hazards. Lockout/tagout procedures should be followed when working on electrical equipment to prevent accidental energization. Regular training and education are essential for electrical workers to stay up to date on the latest codes, standards, and best practices. Electrical work should only be performed by qualified and licensed electricians. Electrical safety is everyone's responsibility. By following proper procedures and taking precautions, we can prevent electrical accidents and injuries.